Hi. So we'll be going through the chapter 1 of P1 of Edexcel IAL's mathematics. And as for my own educational background on mathematics, I finished my A levels back in 2024, and specifically in mathematics I got an A star. So I did P1, P2, P3, P4 and M1, S1. I believe that I'm pretty much qualified to at least be teaching mathematics from A levels. A little background on the courses. P1 and P2 specifically, they are like the same mathematics we have done in O levels, further pure mathematics. So it will be more like a revision. Some parts will be extended, and if we have done those things, then it will be super easy. Otherwise too, it will be easy if we have any mathematical experience, like maybe in high school or something, then these courses are really an easy A. So the first thing we will be seeing is something like this. Now, this is an expression we are very familiar with, but let's see this expression with a little more depth. Here, the a's are expanded to the mth term. This is the mth A. This is the first A, second A, third A. Like this, it's the mth A. So we can say that there are m number of a's multiplied with each other. Same goes for the other one. And there is n times a's. When we multiply these two together, we have mth A times nth a's. So in this line, we actually have m plus m number of a's. To put in perspective, let's say a cubed times a squared, meaning that 3 a's and 2 a's, we have in total 5 a's, thus a to the power 5. Similarly, here we have m plus n number of a's multiplied with each other. That's why the expression is a to the power m plus n. Now this was very easy, I believe. Next one is a to the power m divided by a to the power n, and the expression is this. So one thing we should always know is that when we divide something, let's say 2, it becomes this, meaning multiplied by half. But why? Whenever we divide with something, it also means that we are multiplying that thing. We are just changing the numerators with the denominators. And when we have 2, there is actually a 1 below it, but it's the same as writing 2 because this 1 has no other effect. However, let's say we are dividing a by 3 by 2. It is the same as a into 2 by 3. So remember this very basic thing, that whenever you are dividing with something, you are multiplying that thing actually just by changing its denominator with numerator, replacing each other, and then multiplying. So back to what we were seeing, this means this, which also means this, because whenever you have something like 2 to the power minus 1 per se, it is the same as 1 by 2, because minus power means just swapping the numerator with the denominator, same as division. These two things do the same thing. So what if we have a power like this? It's the same as this. So this thing is turned upside down, you can say, and then the power remains. So that's why it is like this too. And if we follow our first expression, then it means that this, right? Which turns to this. We're adding the power, as we saw, that if both of the bases are same, then their powers will be added when they're multiplied like this. That's a general thing we understand. But why is it minusing? Well, it is because, let's say we have this again, same thing. It means to the nth term, and now we start chopping each other off like this. So this will continue to happen till either the top or the bottom runs out of a's. If it is like this, finally, then it turns to this, which turns to this. And if we have something like this, then the answer will be simply A. But the thing we're doing is minusing everything from denominator from the numerator. So that's why the minus thing, because we're minusing as many a's we have here from here. That's why, in very simpler terms, it's like m minus n. Now we will see another very common expression, another group of expressions. This. It means that we have something like this that will go to the nth term, and this will be multiplied with something like this, and this multiplication will continue for nth time. So we're writing something like this. Here, each of these brackets contain m times a's, and each of these brackets are repeated for n times. So in total, how many a's do we have in this line? We have m times a's, which is repeated n times. So this is the total number of a's we have. M times a's repeated for this number of time. So finally, it's the same as writing a to the power mn, because this many a's are multiplied with each other. That's why this exponent, that's why, is equal to this, which obviously equals to this too, and you know why. Finally, the last one in these laws are this one. And why is this? So when we write this, it means that AB, 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 and it will be repeated for the nth time. So if we simplify it, we see that we have A and B both n times in this line. So it will be written as separated like this, nth time into again n times, and this can be written as an and bn. But be careful about this one thing, do not make this mistake. This is completely wrong, and we will see why. This will continue for the nth time. So if we expand the first, it's like this. And there's many more to expand. Now, if we say that this equals to this, which it is not, then what about this extra term we already have, right? The problem with this is at the end we will have something like this, a to the power n, a very long number of terms, and then finally b to the power n. So these extra terms corrupt this fine expression we could have gotten. That's why do not make this mistake, and I think there will be n minus 1 terms most likely in this space. Now let's solve a few questions and then to the next topic. Tell me what will be the answer. If you said this, then you're right. Now about this one. So we'll first work with these two numerical digits because the like things can be worked off, and these two. The answer is 6 r to the power 5. If we have something like this, guess the answer, we can write it in two ways. One is 1 by b squared, the other this. Both are same things. Let's see what we do with this one. By the way, I'm following the student textbook, which is very useful, and I believe that if you strongly follow that, you may not even need any kind of coaching or tutor. You will be able to score A stars all by yourself if you follow the textbooks. They're that much helpful. What happened is this power is given to both this number and also this number. So this is the same as this number, and when we applied cube on x squared, we know what happened, right? Turn to this. Now further we will work on this, and this is our answer. So these were very easy examples. Let's see a hard one. So what is your plan with this problem? First of all, see that whatever you can take common from either side of this math, top or bottom. Here we can take this in common from the numerator. So the final answer will be or you can write it like this. I took one extra term in common because I could. This is simplified. And the question will be to simplify this expression. That's how we'll simplify it. The next is expansion. I think we also know about this, but let's get through it with some examples. So this has a nice formula we use, but let's do it in the right way. Always be careful in this kind of questions, because oftentimes what we make mistake is that we miscount something, some numbers, we mistake a plus with a minus, so it just ruins the entire calculation. For example, I myself made a mistake. See, I didn't give a square here. Now this expansion, always try to solve questions in a way that is easier for you. In this expansion, we will think that, okay, I will divide with all three of these numbers. I will multiply with all three of these numbers this thing. But that approach is a bit wrong, because it will make things harder for you. Instead, you should plan that I will multiply this with this, so that will simplify things, because like this, it's much more easier. You're only repeating this like twice. I mean, at the end, things might be the same, but still, I think this way you will make less mistakes. When counting, you can do things like this to remember the like things that we're not counting. And we're done with our simplification. Now, as you could see, this is a long simplification. We have about 6 terms we're working with. There can be even more terms. So the rule is to do it calmly and not make any mistake while counting or putting the signs. Let's do one big expansion and then move on to the next one. This is a challenge math. You can try it yourselves and then match with mine. You can this big one. So we are assuming that this one is a single expression, so that's why we can use the a plus b whole square formula. is 2ab, so 2 times x square 2xy y square and y to the power 4. So we're using the famous formula of a plus b whole square, which is a square plus 2ab plus b squared. Now it's just expansion. This is x to the power 4. 4x cubed 7, and this expression is expanded. Now time for this one, which is and finally this. We simplify it. We can always do this, that is, always mark the same type of things you have to make it easier. And you can cut things like this to not repeat count. And I think you have noticed it, but I made a slight inaccuracy. That is, I mean, look at this. Or maybe I haven't made a mistake. Let's just keep on adding. So these two are also chopped off. Finally this. So this is the expansion of this big expression. Now let's check it out. So first of all, let's say we check it like this. Okay, I'll use the calculator now. Yeah, now it worked. So if we use this formula, then it is 3 to the power 4, 4 into 3 cubed into 4, 4, 3 cubed, 6, 4 square, 3 square, and 4 cubed. Okay, I think I overloaded it, so okay, I'll just use the calculator for this one. Please bear with me for a little longer. or you guys can check it out too. It will help with good calculator expertise. And the answer was, right now I checked, 2401, which matches exactly this one. And one important thing, it's just an observation, when you have an expansion like this term and this term will have the same power as here, x to the power 4 and y to the power 4, and in the middle there will be n minus 1 terms. There's 3 terms because the power was 4, 4 minus 1 is 3, that's why 3 terms in the middle. Now we will move on to the next topic, which is factorizing. So let's factorize something we know. X squared minus y squared. It's a memorized factorization that when you have something like this, the factorized form is this, a plus b, a minus b. That's the formula, we call it like this. Let's simplify it and see how this factorization came. So, as you can see, it follows a structure by which we factorize it. And now we will discuss this very structure, but let's get another example to do that. I'll show you how this follows that structure. Let's say we have this. So very quickly you can decide if this is factorizable or not. How to know it? Let's say I do it as plus 10. So when you're given a question like this, your first thing is to see that is this term, the lowest power term, and the highest power term is like this. This is x to the power 0 and this is x to the power 2. So the difference is of 2 powers. If it is like this, let's say minus 11x, not like this, let's say it's like cubed x squared minus 10x, you can still do it, but basically as long as you have something like this, you can do it. We will see that in detail later, but here in this example we will take this term whose power of x is 0 and this term whose power of x is 2, and we will multiply their coefficients. So multiplying this and this gives us 60. Now we will do LCM. I believe this is called LCM. So we got 2, 2, 3, and 5. Now our job is to create a combination that gives us this number. And that combination should multiply to form 60. For example, one combination is, let's say I'm trying 3 times 5 is 15, 15 minus 15 plus 4. But this doesn't work because when you do this, you literally get minus 11, but the answer to its multiplication is minus 60, but we had positive 60. So this thing is not factorizable. You cannot factorize this thing. You can try it in your calculator by using the formula of quadratic equations, and you will see it's that. Instead, what if we had something like this? Minus Now we'll have the same factors. I believe they're called factors. And 15 from here minus 4 from here, and if we multiply these two numbers, then it is minus 60, same as the multiplied answer of these two. And 15 minus 4 is, minus 15 plus 4 is minus 11. Now let's do the factorization. Actually, yeah, there should be 2x. And there you have it. Now I was saying that the above equation can also be put into this structure. How? See, it's the same as saying that the middle equation in xy term is 0. So we're saying it has 0xy minus y squared. So this is not something you will come across because we have two variables, which is very difficult, but here we can still work our way. This has a coefficient of 1, this has a coefficient of 1, x squared plus xy minus xy minus y squared. And I think this is, in this case, we can assume that the entire thing has coefficient. I don't know because I never did this math like this in my A levels, so I might be wrong at some place, but it will very nicely factorize, that's for sure. And we get this very nice and easy a plus b, a minus b formula. So this is factorization. Let's practice another factorization because it's very important. And we have a classic. Next. It is from your student books, question number 4 from exercise 1C. Think about it a little. It seems very familiar. So let's change it to the familiar scenario, but let's do it in my way, the way we just did right now. X to the power 4 plus x squared y squared minus x squared y squared minus y to the power 4. I'm doing it fast because it's just to give you an example. You don't have to do it like this in the exam hall because it might be a bit difficult. And we have done factorization successfully. Now let's do it in the way we are expected to do in our examination. So it can be written as this, right? Then it falls in the formula, so it's a plus b, which is x squared and y squared, a minus b, and this one can be further factorized by the same formula again. And there you have it. And now we have a challenge question. Let's do this and move on to the next one. This is also factorization. So first we need to see the multiplied thing is 9 into 4, which is 3 into 3, 2 into 2. We have to turn this into minus 13. And it has to be two minus signs, otherwise the resulting thing won't be something positive, and the multiplied form of this and this is something positive. So to make it happen, this has to be a minus, because minus minus is plus, so two minuses. And it's very simply this, right away. I have only taken minus 1 as common because that helps. Now this is a very interesting question, and I have a question for you. Tell me by the end of this answer how many bracketed units we will have. Quick. If you said 3, you're wrong, because this will turn to this. However, there is one more. This, my dear student, this thing can be written as this, and then another new factor is added. And we're done. The next thing we'll be seeing is negative fractional indices. We already talked about this. If it is something like this, it turns to 1 by x, turning upside down. What if it is something like y by x to the power minus n per se? It turns to x by y to the power n. Indices, as we know, something else is also important. What if it is in fraction, like this? Well, it means the same as a cubic root. And what if it is something like this, a very odd number like this? It means a has this 7th root, but also a power over it. Like this. Or you can also write it like this. It all means the same thing, because this is the same as this. So remember this, that 1 by anything like 1 by 2 means root over a. And obviously we all know this too, a to the power 0 is 1 for all rational numbers. But how does it happen? Let's say we have something like a to the power m divided by a to the power m, meaning a times divided by a. Everything is divided by everything, and what remains is just a simple 1. But if we write it like this, it turns to a to the power 0. That's why it's always 1, because of this. So when I write something like this, it's very simply just 1. Now I would suggest that you practice some other simplifications. I will show you just 2 of them. So I was confused with this specific question. Let me share it with you. So what does this thing mean, that this entire thing is dividing? So this. What I was confused with was that I thought that the x term was not dividing but multiplied, this x term. But turns out I was wrong, and this entire term is dividing because of this division sign. That's why there is a minus here, by the way. The final answer is this. We will see this last one from these questions and then the next one. Next topic. So this is very interesting. It means, first of all, what is the value of this? This thing is working very poorly. Okay, it's 5. I'm sorry for the inconvenience. So it will be 5x squared. Why? Because this is the same as... Okay, this is the same as writing like this. Times okay, it's a bit congested, sorry. Which is the same as into, and now we know what happened. It becomes 5 times 2, which I have already written here. Okay, next is numerical evaluations of these techniques. This is quite easy. Simply 3. What if this? So the first thing we do is we simplify it, we box it like this. Which then turns to this. And I believe the answer will still remain the same. For some reason this software is not working nicely. Anyways, the answer is same, as you can see. Next, we have another interesting question. Our job is to put values of y in this and express it in the form of this, where both k and n are constants. So let's do it very quickly. The answer is 1 by 4 x. Why? Because x to the power half, 2 into half is 1, and 1 by 16 is the same as 1 by 4 whole square, and then the power half works on it. The power half also works on 1, but 1 to the power anything is 1, thus only 1 by 4 remains. You give a try to this one, my dear student. Try to do this and see if our answer matches. Check it if it matches. What happened? It's only -1, so 16 gets swapped with it's 1, and 16 by 1 is actually 16. We don't write the 1 that's below it. Same goes for x squared. It turned upside down, which is 1 by x squared, and then it is the same as this. Or you can think of it like this, that x squared into -1 happened, which is more logical. Practice this maths and it will be quite helpful. Next, we have a very particular term, surd. It means when you put a root over a number that doesn't have any square of that. For example, this is a surd because you cannot remove this root without making it an irrational number. This and this, it will be never ending. See? This is not the end of it. This is just a rounded up answer here. It will continue forever. Because there is no number whose square is 3. Similarly, let's say this is also a surd. By definition, if n is an integer that is not a square number, then any multiple of root over n is called a surd, square root over n. So basically in this specification of P1, we'll be only dealing with surds formed by square root. So this is most likely not needed. Surds like this and this is very much needed. Now, from our previous understanding, I think we are pretty clear about two things. That is, this equals to this, and this equals to this. So now let's do a few maths with this. Often in calculator we will see that they come in a nice form, but let's see it ourselves. It is, you think how I got to this form by yourself. It will help you understand better. It becomes, because this square is cancelling this root, because it is simply 2 to the power half into 2. Okay? Next is this. So we know that it's the same as this times this, which is simply just root over 5. How? This and this cancels out. We only have 2 and 2. These 2 and 2 cancel out each other. We only have root over 5. Finally, a very lengthy one. These are all example maths from the book, so you can try them out if you want. So we have to now see how to simplify. This can be simplified because 6 is a multiple of 6 can be factored to 2 and 3. And both of each's square root is a third. So root over 6 cannot be worked with. Here it is 2 times 2 squared, 2 cubed actually, times 3. Now, this is of not work because we don't need a 3 but a 2, so we will do it like this. 2 squared, 3, all of this has square root. So it turns out to only 2, 6. Now this is the simplification of root over 24, this thing right here. So finally it becomes 2 into 2 into root 6, and we already have a root 6th term here. So what it means is that we have 5 root over 6 and we are minusing 4 root over 6's. So how many root over 6's do we have remaining? We only have 1 root over 6 remaining. Now we come to this term, this one right here. It's a big term, but let's just use the calculator for this. This is actually a big term, but surprisingly, it is the same as this. Funny, right? So it turns to only 7 root 6. And we have only 1 root 6, or to write it much more simply, now it's a very easy calculation. The answer is 8 root 6's. We will see one more math from this and then we will go to the next topic. Let's have a simplification math, expansion math. I'll be fast now, so I hope you keep up with me. So because this last term is multiplied with this, that's why it turned to a rootless number, because, well, whole squared, and this is 3. So that's why it turned out like this. The resulting answer is minus this. And this is the answer. So next we'll be seeing rationalizing denominators. Why? Because denominators can be irrational, like this. And we don't like it in maths. It creates some problem while calculating. So what we will do is we will multiply it with 1. And 1 doesn't change the number. That's why it's so helpful. This is the so-called 1. This thing. Because it equals to 1. But when we multiply it like this, we get a very interesting this, which turns to this thing. And now we don't have a root in the denominator, which will be helpful for us. However, there is a slight problem. This is the said problem. What will we do now? Because if we multiply with root over b, then surely we'll get a root over b here, but the denominator will turn to something like this. It will turn to a root b plus b. And we can forever continue this, and there will always be a root in the denominator. To solve this problem, we will multiply it with this. Look very carefully. This is our a, this is our b, and when we multiply these two together, it turns to a plus b into a minus b, which is the formula of a squared minus b squared. Now what was b again? This b was actually root over b, right? So it turns to simply a squared minus b squared. That's why when we do this here, it turns to a squared minus b squared, and the numerator will get this. This is how we generally rationalize denominators for our A levels. This becomes simply this. I don't need to explain it. I think it's quite understandable from what we just learned. This will turn to again, I think we all know why it turned out this way. The equal sign is not working today nicely. You can try this yourself and see if you can do it. I will do the next one for you. So think, what do you have to add or subtract? You will have to simplify it first, actually, because it is a squared minus 2ab plus b squared, which is 4 minus 2 root 3 by 1. Now we know what we have to do. It will turn to this. 4 plus 2 root 3, and the bottom will turn to this. And the resulting answer is this. And we can simplify it a bit more by dividing by 2, which will leave us with 2, 2, and this. We have reached the ending of the chapter. Let's try a very easy math. Challenge maths. If they're easy, that's good for us. Using challenges by the Edexcel is easy for us, right? This is a very easy one. Simply a plus b whole squared, so it's a plus 2 ab plus b squared. Quite easy. The next one is a bit tricky, and I want you to solve it by yourself. I'll show you how, but I expect you to do it. And this will continue. See what's happening and think how to solve it. Pause here and think, and I'll solve it now. So, we will be multiplying each of this with the one we talked about, the very funny one. For example, in the first one, we'll multiply it with this. And for each of these, they will be multiplied with their specific special one. For example, for this, we'll multiply with... You understand what I wrote. So when we multiply, what do we get after that? For example, in this one we get root 1 minus root 2 and 1 minus 2. It will have, the next one will have root 2 minus root 3, 2 minus 3. Next one will be 3 minus 4, 3 minus root 4. And we will continue to the last term. If you simplify it now, see that here it remains only minus 1 in the denominator. Here it will only remain minus 1. All of them will only have minus 1. So this minus 1, we take this minus 1 because it is like this. minus 1, and we multiply it to this because it's the same thing. Because this minus 1 will come in front and then it will go here, and when that happens it becomes minus this plus this. So the resulting thing will be like this. And it will go on to plus root 25, and all of these terms will cancel off each other, all of this, till we only have this and this. So this one is minus 1, this one is 5, and the answer is 4. We're done with chapter 1 of P1, algebraic expressions. I suggest you to go through the chapter review and the examples if you have any problem. Now, I'm not going to be taking classes like this on YouTube or any other platform like this. My ambition is to start a batch of students, and we will go through the entire syllabus of the mathematics course for A levels, AS and A2. I plan to start the classes by the next month, so we have about 2 weeks left before the classes start. This is just a demo exemplary class for you to know how the classes will be. If you understand what I'm saying, if my classes are clear enough, do question me if you join the classes, and till then, bye.